Today's notes are on two-step equations. As a reminder, equations are when we indicate that one expression is equivalent to another. For example, 2 plus 3 equaling 5. That is technically an equation. The kind of equations we're going to be seeing is 2x plus 3 equals 5, and trying to figure out what that missing number must be. That's because we're looking at two-step equations. The two-step indicates how many steps it's going to take to solve by isolating our variable to be x equaling some number. Our main idea is the same as with our one-step equations. How do I undo what was done to the missing number? For example, if I have some number, n, and the first thing I do is I multiply it by 2, and then I add 10, and that gives me 50. We need to undo in a particular order. So that's indicating my missing number. The first thing that we did was we multiplied by 2. And then the next thing we did was add 10 to give me 50. So to undo what was done, we have to go in reverse order. I have to first undo that add 10 by subtracting 10. And that brings us to 40. And then that first thing that I had done originally was that multiply 2. That's going to be the last thing I undo. Instead of multiplying 2, I divide 2. And that gives me my original number of 20, which makes sense because if I take 20 and multiply it by 2, it gives me 40. And 40 plus 10 gives me 50. So I know that n must be 20. Now, in efforts to not have to draw that flow chart every time we solve a problem, we're instead going to be solving them the same way we did our one-step equations by using our inverse operations. Here, I have some number x. The first thing that happened was it was multiplied by 2. Then, the second thing that happened was it was subtracted by 9 to give me 29. So 2x minus 9 equals 29. I'm first going to get rid of that minus 9. If I add it to one side, I have to add it to the other. That leaves me with 2x equaling 38. Now, if a number is being multiplied by x, I undo that multiplication with division. So I divide by 2. When my variable is isolated, I get 19 as my final answer, which makes sense. If I were to go and check my work, 2 times 19 minus 9 should give me 29. 2 times 19 is 38, and 38 minus 9 is 29, so I did it correctly. For example 2, I have some number x, and the first thing that happened is it was divided by 4. That's first, and then the second thing that happened was we added 8 to give me my final answer of 3.3. So x divided by 4 plus 8 equals 3.3. The first thing I'm going to undo is that plus 8. My inverse operation is then to subtract 8. And if I subtract it from one side, I have to also subtract it from the other. I'm left with x over 4 equals a negative 4.7. My next step is to undo that divide by 4. And I'm going to do that by multiplying by 4. If I do it to one side, I have to do it to the other, and I'm left with x equals, and it's going to be a negative because it's a positive times a negative, 18 and 8/10. For example 3, we're looking at fractions again. Remember, when we're adding and subtracting fractions, we're going to be needing a common denominator. If we're looking at 1/2, 2/3, and 1/4, and we're trying to figure out what number does 2, 3, and 4 all go into. And the smallest number would be 12. This gives me 6/12, 8/12, and 3/12. Let's rewrite our problem with common denominators. I have 6/12 f, subtract 8/12 gives me 3/12. The first thing I'm going to undo is that minus 8/12. And if I do it to one side, I have to do it to the other side. that leaves me with 6/12 f equals 11/12. Now I'm no longer adding and subtracting. So I'm going to simplify these again. I have half of f equals 11/12. And to undo a 1/2 being multiplied, I divide by half or multiply by 2 on both sides. Now my f is equal to 22/12, which simplifies to 1 and 10/12, or 1 and 5/6. This was a lot of steps for one singular problem. If you got lost or stuck, it would be helpful to go back, rewind, and watch it again. And if you're still finding yourself stuck or confused, make a little note in your notebook. I don't understand why we added 8/12. I don't understand why we needed a common denominator. Why did my numbers get bigger? Why did I find a common denominator only to undo it later? Whatever your question is, it's helpful to go ahead and email your teacher so that we can cover that when we do our direct instruction lesson. Let's see how well you're doing on your own. Pause the video, try, and play and check your answer. If you are able to find your mistake, oh, that makes sense, then that's great. Just make a note of it in your notebook. But if you're going, I see how it's different, but I don't understand why my way is wrong, again, this is a time to email your teacher. All right, let's do it together. I have 3r plus 6 and 12/10 equals 9 and 33/100. I'm first going to use that inverse operation on that plus 6 and 12/100 by subtracting the 6.12. And if I subtract on one side, I have to keep it equivalent by subtracting on the other side. I'm left with 3r equaling 3.21. I'm going to use my inverse operation for multiplying by dividing, and r equals 1 and 7/100.